Welcome back, dear students. So let's continue with the exercise 20C. Today we will begin with question number C. Question says the adjacent sides of a parallelogram are 21 centimeter and 28 centimeter. Okay, so let us consider this particular parallelogram, and the adjacent sides are given to be 21 centimeter and 28 centimeter. Okay, so let me take this side. Okay, so this is my side AC, so let me take this to be 21 centimeter and the adjacent side is given to be 28 centimeter. Okay, now all of you know in a parallelogram, so this side and this side, they will be equal, so that's why this will also be 21 centimeter, right? And similarly this side and this side, they will be equal, so let me take this to be 28 centimeter. Okay, now here it is said that if one of the diagonal is 35 centimeter, so let's consider this diagonal. See, we have got two diagonals, so let us consider this diagonal to be 35 centimeter. Okay, you need to find the area of the parallelogram. Okay, now in order to find, okay, so first what we have done in the diagram is we have given the names, that is ABCD. Okay, so let me write, let ABCD be a given parallelogram with, okay, with the sides, okay, AC equals to BD, AC equals to BD equals to how much? 21 centimeter, and the other side is CD, AB equals to CD. Okay, AB equals to CD equals to 28 centimeter. Okay, now let diagonal BC, okay, so let diagonal BC be equals to 35 centimeter. Okay, now see, if you want to find the area of this, okay, if you want to find the area of this parallelogram, we will observe this diagram. If you look at this diagram, okay, so if you look at this diagram, okay, A, B and C, if you look at this diagram, what kind of figure is this? Isn't this a triangle? Obviously yes, right? Now what are the three sides of this triangle? The three sides are given to be 21, 35 and 28, right? So we will find the area of this particular triangle. Now if you look at this triangle BCD, you know BC is 35, BD is 21 and CD is 28. So basically triangle ABC and triangle BCD, they are equal triangles, right? In fact, they are congruent triangle, we can say. Okay, that means the area of one triangle will be same as the other one. Okay, so here what will I do is I will first find area of one triangle, okay, and I'll multiply that area by 2. Okay, so because we have got two triangles, right? So we'll multiply that area by 2. That will give me the area of this parallelogram ABCD. Okay, so therefore, you know, okay, so first let's find what is the area of triangle ABCD. Okay, so to find, just wait a minute. Okay, so to find, okay, so let's observe in triangle ABC. Okay, so in triangle ABC, let me take A equals to this one, okay, AB, okay, which is equals to 28 centimeter. B equals to, let me take B to be anything, so let me take B equals to AC, which is equals to 21 centimeter, and let me take C to be equals to BC, which is equals to 35 centimeter. Now if you have got three sides, now you know there is one formula called Eron's formula, which can evaluate your area of the triangle, isn't it? So from here, okay, so therefore your semi-perimeter S becomes A plus B plus C divided by 2, right? So it turns out to be A is 28, B is 21, C is 35 by 2. So let's quickly evaluate this. So this turns out to be 28 plus 21 plus 35 is 84. Okay, 84 by 2 will be 42. Okay, it will be 84 by 2, which gives me 42. So this is the value of S. So therefore area of triangle ABC, so it will be equals to, so kindly look at the area. So you know Eron's formula says it will be S into S minus A into S minus B into S minus C. Okay, so let me put the values here. So it becomes S is how much? S is given to 42. So 42 into 42 minus A. A is 28. Okay, now next is S is 42 minus B. B is 21. And next is S, that is 42 minus C. C is 35, right? So when you evaluate this, this turns out to be, we have 42. So into, we have 42 minus 28. So 12 minus 8 is 4. So it will be 14. Okay. So 42 minus 21 will be 21. Into, we have 42 minus 35 will be 7. Okay. Now, if you evaluate this, if you find the square root of this, first and foremost, if you multiply, let me directly write down your square root. Okay, so your square root turns out to be exactly 294. Kindly check. Okay, so it turns out to be 294. Unit is centimeter, so it becomes centimeter square. Now, see, this is the area of what? Triangle ABC. But we are asked to find area of the parallelogram, right? So therefore, area of parallelogram is equals to, so it will be, I told you it will be double the area of triangle ABC. Yes, so 2 times area of triangle ABC is how much? Just 294. So when you multiply this, you get your answer to be 588. Okay, so that means, all right, so your answer will be 588 centimeter square. Okay, so you may pause the video and note down your solution. Let's move to next question. So here question says the diagonals of a rhombus are 18 centimeter and 24 centimeter. So for your reference, I have drawn the diagram here. So you see ABCD, okay, or ABDC. Okay, name is ABDC is a parallel or is a rhombus. Okay, just wait a minute. I think I need to make a correction here. ABDC. I'm sorry, this is not ABCD, it is ABDC. Okay, so this is not ABCD, it is ABDC. Okay, so let ABDC be a given parallelogram with all these measurements, right? Okay, let's move to next question. So again, here, this is my rhombus with the diagonals to be 18 centimeter and 24 centimeter. So let me take AD to be 18 centimeter and let me take, okay, so this is my, this entire thing is my 18 centimeter and this is BC is my, okay, so let me directly write down the necessary details. So let ABDC be a rhombus with diagonals. So the diagonal AD is equals to 18 centimeter and the other diagonal, that is BC is equals to 24 centimeter. Okay, now number one, you need to find its area, right? So therefore area of the rhombus. Now all of you know formula for finding area of the rhombus is half into product of the diagonals, right? So what are the diagonals here? The diagonals are AD and BC, right? So half into product of the diagonals. Now let's put the value. So half into AD. AD is 18 and we have BC is 24. So you can do the cancellation, right? So 9 4s are 36, carried over 3, 9 2s are 18, 18 plus 3 is 21. So these many centimeter square will be the area of this rhombus. Okay. Now there's one very important property that you need to know about rhombus. So you know the diagonals will be intersected, right? Now the diagonals will not only be intersected, okay, but it will get bisected at this point. So let me call this point to be point O. Okay, so diagonals gets bisected at 90-degree angles. Okay, so that means this, you see this. Okay, so this is a very important property which you might have learned in your junior class or most probably in your class 7. Okay, that means the rhombus, okay, the diagonals of the rhombus always gets bisected in 90-degree angle. Okay, so this is a very special property. Now as I told you, it will get bisected. So that means, see, if AD is 18, now AO, okay, so this is going to be how much? It is going to be exactly half of 18, which is 9 centimeter. So this is going to be my 9 centimeter. Okay, similarly, you know, BC is given to be 24. So that's why BO or OB, you can say, OB will be half of 24, which is 12 centimeter. Okay, so this is 9 centimeter and this is going to be 12 centimeter and this is 90 degree. Okay, so number 2, let me find what is the length of each side. That is, let me find AB. You know, in case of rhombus, all the sides will be equal. So better find AB. It will be equals to finding this, this, this or this. Okay, so using properties of rhombus. Okay, so I told you, using properties of rhombus, we have AO equals to OD, which will be equals to 9 centimeter, right? Next property says that BO will be equals to OC, right? So next is BO equals to OC, which will be equals to 12 centimeter. And one more very important property is this angle. Okay, and we have angle AOB is equals to 90 degree. Okay, so therefore in triangle, let's say this AOB, in triangle AOB, now since this is a right angle triangle, all of you know, okay, side opposite to 90 degree, that is AB becomes my hypotenuse. Okay, so by Pythagoras theorem, we have the side AB is hypotenuse, so hypotenuse square is equals to perpendicular square plus base square. Okay, now let's put the values. Now you know AO is how much? AO is 9 centimeter, so A square is 9 square, plus we have BO is, or BO or OB is 12, so it becomes 12 square. Okay, so AB square turns out to be 9 square is 81 plus this is 144, right? So when you add these two, you get 225. Okay, so therefore, so I don't have space here, let me write it here. So therefore we have AB equals to AB square is 225, so that's why AB will be root over 225, which will be equals to how much? 15 centimeter. Okay, so therefore AB represents length of each side, yes or no? So therefore length of each side is how much? Length of each side turned out to be 15 centimeter. Okay, so this is my second answer. Now third answer. Okay, so third answer will be perimeter. That's what they're asking us. So perimeter will be, now all of you know length of each side. Okay, so that means all the sides will be equal. So that's why perimeter will be 4 into each side. Okay, so it will be 4 into each side. That is 4 into each side is 15. So that's why this turns out to be how much? 4 into 15 is 60 centimeter. Okay, so this is my third answer, this is my second answer, and this is my first answer, right? So you may pause the video and note down your solution. Okay, so we have one more question of similar kind, okay, where there's a case of rhombus given to us. So perimeter is given to be this much, one diagonal is given to be 16 centimeter. Okay, so perimeter, so given is, so let me first write whatever is given to us. Perimeter equals to 40 centimeter, and all of you know perimeter is 4 into each side, right? 4 into each side is 40. So bring this 4 to the denominator, you get each side equals to 40 by 4, which is equals to how much? Which is equals to 10 centimeter. That means this is, okay, so that means this is 10 centimeter, this is 10 centimeter, this is 10 centimeter, okay, and this is also 10 centimeter. Okay, so these are things that you need to remember. Okay, right. So we got each thing to be 10 centimeter now. Okay, now you need to, okay, one diagonal is given. Okay, so you can take either this or this. So let's take this to be 10 centimeter. Okay, so if you take this to be 10 centimeter, I don't know what's wrong here, I'm not able to write, but okay, so if you take this to be 10 centimeter, okay, 60, I'm sorry, one diagonal, that means if you take AD, okay, so if you take AD equals to 16 centimeter, then you write O here. Okay, so AO will be equals to, obviously using property, it's gonna be 8 centimeter. So this is going to be 8 centimeter. So again use Pythagoras theorem here in this diagram. In this diagram you put Pythagoras theorem, you will be able to find this. Okay, so if you are able to find this, you will be able to find another diagonal. Just multiply this by 2. Okay, so you get your another diagonal. Now you have one diagonal, and if you get another diagonal, you will be able to find its area also. Okay, so what you do is let the diagonal AD equals to 16 centimeter. Okay, which gives me AO equals to 8 centimeter. Okay, again you write in triangle AOB. Okay, then use Pythagoras theorem like earlier one and find the value of OB. Okay, so that's how you need to do this sum. Okay, so I am leaving this problem for you to complete by yourself. Okay, so complete the sum and send it to me in my mail. So with this we close for the day. Thank you very much.